formability analysis is relevant to the time it was performed. It's relevant to the recipe at the time you perform formability analysis. It's not a dynamic moving picture of anything. It's a condition at that point in time. But formability analysis includes circle grid analysis, includes thickness strain analysis. We use automated and camera-based systems now, not just manual circle grid. We create forming limit curves and forming limit diagrams, and we position points on those curves to tell us effectively what's the nearness to failure, because that's what we really want to know. We want to know how safe this material is and how stable this material is. So that's why we use formability analysis. Certainly your applications people have a lot of experience doing this, but they're also working on new vehicle programs. So oftentimes they're not available to you to problem solve in the field. But it's a great tool. Let's start with circle grid analysis. Let's talk about that. Circle grid analysis basically means we're going to etch circles on a blank, and then we're going to form that blank. And when we form that part, those circles deform into ellipsoids, and the dimensions and shape of those ellipsoids tells you what the deformation mode is, and it also tells you the extent of strain in those circles or in that area. Those circles can change very slowly over some geometric features, or they can change very dramatically. When you're doing trim scrap and other measures, or you're using templates and you're measuring thickness, how sensitive is it that you be precise? Well, because some materials and some parts are very, very sensitive, that precision is quite important. But what we're going to do when we do circle grid is we're going to make sure we date it, because it's relevant to the recipe at that time it was formed only. And things change over time. So in this particular part, you can see there's wrinkles, unacceptable wrinkles at the bottom. You can see the location of the bead. This is a draw shell. And we're going to measure circles throughout this panel. And typical panels have a multiple number of areas that traditionally you need to worry about. Draw walls, corner areas where there's very significant features, where there's great depth, or where there's tight radii. Those are areas that can cause strains, and we typically need to make sure we look at those areas. So what we do is we form that circle gridded panel. Now we measure the extent of strain in those circles, and we plot those circles. We chart those against what we call a formability curve that's placed on a strain diagram, and that becomes a formability diagram.